I'm Cody Dana, and our project is titled Using Machine Learning to Build and Train an Intelligent Car Agent by Shawn, Allison, Brandyn Buck, Cody Dana, Tyler Deuty, and Nawfal. The project is sponsored by Ashraf Ghaffar, and the project instructor is Hasan Davulcu. Innumerable deaths among teenagers are caused by distracted driving in the US. Although autonomous vehicles are already on the road, they present challenges of their own, such as navigating in unusual weather conditions, reacting to unusual behavior of other drivers. Our solution is intended to build toward mitigating potential damages from distracted driving. We created an intelligent car agent that is trained to differentiate whether a driver is distracted or not behind the wheel. To do this, we provided training data produced from the vehicle sensors. The end result is software that is able to accurately predict the level of driver distraction based on the data collected from the ASU driving simulator. This is Cody Dana, and I'll be talking about the background of the project. Driver distraction is the #1 cause of death among teenagers in the United States. In 2015 alone, 3,477 people were killed, and 391,000 were injured in motor vehicle crashes involving distracted drivers. To advance the progress of preventing driver distractions, we are creating an intelligent agent that will monitor driver behavior patterns. From the level of distraction assessed by the intelligent agent, the agent will be able to differentiate between if the driver is distracted or not. Our solution to the mentioned statistic is to build an intelligent agent towards mitigating accidents and potential damages caused by distracted driving. So, the purpose of the project is to assist in mitigating the consequences of driver distraction. And to assist in this purpose, we are employing existing artificial intelligence frameworks towards building and training an intelligent car agent that can monitor driver behavior patterns. With this, the agent will be able to differentiate between distracted and non-distracted driving. In addition, the purpose of the project for us students was to get a feel of what it's like in the real world. Careful planning, solid communication, and conducting meetings towards an important project are all part of genuine and valuable process we get to experience.
My name is Brandyn Buck. Utilizing the ASU driving simulator located at the Polytechnic campus, we collected data from 35 volunteers who use the simulator under distracted and non-distracted conditions. We created 2 instances of the intelligent car agent. One instance utilized a deep neural network, while the other utilized the recurrent neural network. The data collected from volunteers was fed through both neural networks in order to train our intelligent car agents to recognize distracted driving in different weather and time of day scenarios. The machine learning principles used in our project architecture and the utilization of deep and recurrent neural networks are prevalent in the current industry. Using backpropagation and multiple hidden layers, the intelligent agents were able to learn and derive different levels of driver distraction. A variety of tools and technologies helped us complete our project. We used the Python programming language, Google's TensorFlow libraries, the ASU driving simulator, GitHub, and the Visual Studio Code development environment.
Hi, my name is Shawn, Allison. The decisions we made toward building our intelligent car agents include the network design and neural network hyperparameter choices. We altered various hyperparameters of our neural networks, such as the training rate, number of hidden layers, batch size, and other factors, so that the networks would achieve an optimal prediction accuracy. We also had to decide upon which tasks that the volunteers should execute to emulate driver distraction during the data gathering process. We also had to decide how we would schedule volunteers on days that worked with the team's availability. The project was a huge learning experience and a great success. We were able to formulate a deep neural network with acceptable accuracy. Along with this, we were able to create a recurrent neural network with low loss. Overall, we were able to demonstrate classification of driver distraction through the use of machine learning methods and raw sensor data.
In the end, the intelligent agents were able to learn behaviors in a similar manner as biological neural networks and estimate the level of driver distraction. We obtained invaluable practical experience and communication ability due to scheduling volunteers and communicating with them throughout the process. In addition to maintaining communications with our project sponsor and team members, we have also enhanced our technical writing skills by working on project documentation, such as our IEEE software requirements specification document. We've gained advanced development experience that cannot normally be obtained from a standard undergraduate curriculum. The creation of neural networks, research, dataset generation, and implementation will assist in accommodating us with project complexities in the industry.
My name is Tyler Deuty. We were able to gather valuable data sets corresponding to non-distracted and distracted driving from volunteers who used the ASU driving simulator. We also learned how to utilize Python with TensorFlow libraries to create deep and recurrent neural networks and feed data into those networks. Throughout the project, we learned a lot of lessons. A huge lesson that we learned was to not underestimate the difficulty of writing neural networks. None of us had previous machine learning experience at all, and so it took a lot of time and research to successfully create and train intelligent car agents. Another lesson that we learned was not to rely on hardware to work all the time, since we had some issues with the systems related to the driving simulator. Other lessons include having experienced drivers as volunteers for good quality data, and being more thorough with the logistics of the project beforehand. For example, the remote location of the simulator used to collect the data became an unanticipated logistical challenge.
My name is Nawfal. In conclusion, the creation of neural networks, the ability to do proper research, being able to generate data properly, and merging all these factors together for proper implementation will assist in accommodating us with project complexities in the industry. We realize that data collection is a very rigorous process and believe that teamwork goes a long way in helping break down a difficult project into smaller, more manageable goals. Different things can be done to improve this project in future work. Improvements of our neural network can be made by obtaining more training data from the simulator. We could also test our neural network in the real world with an actual car, utilizing the sensors provided by an advanced driver assistance system. Additionally, we could have the vehicle execute precautionary actions depending on certain levels of driver distraction. Lastly, we can also utilize both deep and recurrent neural networks towards different projects.